Okay, so for 21.74, it's asking you to find which of those two spheres has the positive charge. And it's also asking you to find the magnitude of the electric field, and the values are already given there. So the ball on the left is going to be the one with the positive charge because it's being deflected in the same path as the electric field. What that also means is that its electric force, Fe, is acting in that same direction. So now to solve part B. As you can see, I already have my drawing copied. I also have my values here, and I also have the explanation for part A just to save time. And so what you're going to do for part B is you're going to set E equal to the sum of the forces over Q, and that's just going to be T sub X, so that's the tension acting in the X direction, plus F over Q. And so T is going to be equal to mg over cosine theta squared over 2. Actually here it's going to be T sine theta plus F over Q, because Tx is equal to T sine of theta. And so D is going to equal 2L sine theta over 2. And so what all that is going to give you is E equals mg tan of theta over 2, because these two here, this one's going to be above, this one's going to be below, so that's going to form tangent over Q plus KQ over 4L squared sine squared theta over 2, because that is D squared. And so now what you're going to do is you're just going to plug everything in. E equals 6.8 times 10 to the negative 6 kg, because it's milligrams up here, so it's 10 to the negative 6 kilograms. So now what you're going to do is you're going to add 9.8 meters per second squared, because that's gravity, and tangent of 58 degrees over 2 over 72 times 10 to the negative 9 coulombs, because that is nanocoulombs. And so now you're just going to add the other part, so it's just going to be K. Actually, I'm going to write that out just so there's no funny business. 9 times 10 to the 9, which is the value of K, and that is 72 times 10 to the negative 9 coulombs. And so D squared is just 0.53 meters squared times sine squared of 58 degrees over 2. And so all of that, what all of that is going to give you, it's already been, sorry, so that's a good visual. What all that's going to give you is 0.513 times 10 to the 3 Newton per Coulomb plus 2454.13 Newton per Coulomb. What all that is going to give you is 2967.13 newtons per Coulomb. So that's how you solve 21.74.